This lecture considers the history and future of human reactions to artificial intelligence and when people have imagined something as artificial general intelligence, or AGI. I'll mostly focus on these three questions. How have people imagined AGI over the centuries? How do researchers think we might approach AGI? And how have people reacted to non-AGI that seems like AGI? So let's start with the first question. Ever since the Bronze Age, there are stories of people having built not just statues, but statues that move themselves, automata, self-moving things. Many of these stories claim that the statues behaved like people. Both in Greece and in China, there are stories in antiquity of artificers building automata that made people believe they were real people, even though they were importantly limited in some ways. Daedalus is said to have built a giant out of brass that he presented to King Minos of Crete to guard the island. And Yan Shi is said to have presented an automaton to King Mu of Zhao that walked and sang and flirted with the ladies of the court. Now, it's unlikely that anything as advanced as those descriptions of automata was ever built. But given the surviving writings that we have from antiquity, including the work of Hiero of Alexandria, depicting the use of steam and hydraulics and pumps and wheels and all sorts of other things, it is likely that at least some self-moving statues were built, and that these ancient stories just represent overenthusiastic ancient hype about artificial intelligence, comparable to many things that we've experienced in recent decades. Unfortunately, none of the ancient automata that were built have survived, so we don't know what their actual capacities were. Though one little bit of ancient machinery was discovered on a shipwreck off the island of Antikythera, and it seems that this machine was probably part of a model of the motion of the planets in the sky. Now, we don't know much about the further development of machines of this sort over the next several centuries. We believe that whatever technology was present in antiquity was lost in Europe but preserved in the Islamic world and in Asia. Around the 12th century, Europeans started translating Arabic texts, including ones about mathematics and calculations, creating words like algebra and algorithm from Arabic words, as well as borrowing ideas like alchemy that eventually led to modern chemistry. One of the important figures in the transmission of this Eastern knowledge back to Europe was Roger Bacon. In addition to the many real things that Roger Bacon did, including bringing back Aristotle's idea of empirical science and documenting the Chinese method of producing gunpowder, both through Arabic sources, he was said by contemporaries to have built a head out of brass that could actually answer questions about the past or the future. And in the Jewish communities of Eastern Europe in the medieval period, stories grew up about a rabbi who had created a man out of clay and brought him to life by inscribing a word either on a parchment and putting it in his mouth or on his forehead. This sort of creature came to be called a golem, and by the 1600s, it was in fact said to be the defender of the Jewish community of Prague. Now, neither of these stories depicts the being as a true general intelligence. The brazen head can't do anything but answer questions, though it does have a lot of knowledge. And the golem does not speak, though it does engage in a lot of practical actions to defend the Jewish community. These ones are really more magical ideas than the ancient stories of automata, but again, they do reflect the idea that people suspect there is more power of life in some possibilities than there really is, although there are still important limitations in these artificial beings. By the 1810s, thinking about artificial intelligence was based on more scientific ideas, but it was still extremely speculative. Now, in this case, it was clearly presented as fiction. The German author E.T.A. Hoffmann wrote a story about a clockwork mechanic who built such lifelike automatic dolls that a young man fell in love with one of them while she was dancing. And this story was later turned into a ballet, Coppelia, and was used in an opera about E.T.A. Hoffmann's stories. Another one of Hoffmann's stories was turned into a much more famous ballet about a nutcracker that comes to life, though that's in a dream, and so it's not usually considered a story of artificial intelligence. The English author Mary Shelley, around the same time, was invited, along with several other friends, by Lord Byron to stay at his castle near Lake Geneva and write ghost stories during this one uh, rainy summer. Inspired by some of the late night conversations that people were having about the theory of electricity that was being developed in Italy and some experiments conducted by the Dr. Erasmus Darwin in England using electricity that seemed to give life to a noodle, she wrote a story about a German scientist, Victor Frankenstein, who uses electricity to create life out of dead body parts. Now, coincidentally, just a few years before she wrote this story, Erasmus's grandson, Charles, was born. And Charles would, of course, become much more famous later on for discovering some real facts about how life works. And her host, Lord Byron, had recently run away from his family after his wife gave birth to a daughter, Ada, who would herself become famous later on for doing important early work that eventually led to the development of computers. Now, neither Hoffman nor Shelley presents their story as real, the way the ancient and medieval ideas had been. But they are trying to come to terms with the idea that progress in modern machinery and science might someday either produce something emotionless that a human might be fooled by and fall in love with, or might produce something truly alive that a human might misinterpret and mistreat. These themes became more and more common in fiction throughout the 19th century as science and technology progressed. And by the turn of the 20th century, electromechanical beings were appearing in many works of fiction. Now, one last historically influential fiction I'll mention is one that came out just after the end of the First World War, when the German, Austrian, Russian, and Turkish empires had been taken apart into several new nation states. Russia had just undergone its communist revolution, and the fascist movement was rising in Italy. And in the new country of Czechoslovakia, the author Karel Čapek was worried about these themes of communism and fascism taking over. And he wrote a play about oppressed workers undertaking a violent revolution, but then destroying the ability to keep society going so that all of humanity ends up going extinct. Now, the interesting thing in Čapek's play, these workers were not humans, but were artificial beings made in factories out of biochemical material. And he invented a new word for these workers. The Czech word rab means slave, and robot meant the forced labor that a serf would provide to a lord. And so he called these workers the roboti. And when the play was translated into other languages, including English in 1921, this word was taken for these workers, and it gave rise to the modern word robot. While Čapek doesn't directly base his robots on any technological innovation of the time, he's one of the first authors to indicate both a faction of humans who recognize that these robots have feelings and emotions and try to end their oppression, but also depicts the robots overthrowing the humans and eventually causing their own death, even though they were trying to bring about their freedom. And in this story, Čapek is one of the first who means for us to identify just as much with the robot as with the human oppressor or victim. Now, after the middle of the 20th century, when the development of computers began to show that at least special purpose artificial intelligence was possible, and Alan Turing's work on universality gave reason to believe that artificial general intelligence might be possible as well. Turing presented a test for how we might recognize the presence of general intelligence, in that humans would be able to have meaningful conversations, so meaningful that they couldn't tell the difference between a computer and a human. But it wasn't clear how this would come about. In the early days of artificial intelligence, there were many ideas for how to process information, but not much practical success yet. But a professor at MIT, Joseph Weizenbaum, had the idea of making a simple computer program that just processed text in a way that imitates a certain kind of psychotherapy. He was intending this to be a satire of the particular form of psychotherapy that he was imitating, Rogerian therapy, in which the therapist tries to never say anything informational at all and always turn the conversation back to the patient and just ask more questions about anything the patient has already been talking about. Weizenbaum had initially wanted to discredit this form of psychotherapy by showing even a simple computer can do what it does. But what he discovered is that many people, including his own secretary, started to value the conversations that they thought they were having with this therapist, Eliza. In a sense, what he ended up showing was that even though the therapy was simplistic enough to be implemented by a computer program of that era, it was still tapping into something important and emotional for people. This suggested that, in addition to the failure mode suggested by Frankenstein and RUR, where artificial intelligence might have an inner life that isn't properly appreciated by humans, there's also a failure mode where humans project an inner life onto a device that doesn't really have it. This may be what happened in antiquity with the stories of the automata of Daedalus and Yanxi. Now, in the 1970s and 80s, there were many more fictional discussions of artificial intelligence, depicting a range of origins and capabilities, and there were a range of new systems that could do various special tasks, but none of them approached true general intelligence. However, by the end of the 1990s, this idea started becoming more prominent again, and the success of Deep Blue at chess led IBM to start a project to develop a computer that would play Jeopardy, which seems closer to testing a wide range of human knowledge. Meanwhile, the new corporation Google, which originated in 1998, had a lot of ambitions. Borrowing Turing's idea of universality, the founders of Google, Larry Page and Sergey Brin, were confident that just by processing information and helping people find information they want, they might be able to enable a kind of general intelligence. Their search algorithm was based on figuring out which sites were the most authoritative on the basis of recommendations from other authoritative sites, and they would use a user's query to figure out what they want. They soon started expanding this. Their AdSense program observed user clicking behavior to figure out which results a person would find valuable. Serving someone an ad for a product that they're looking for is good for both the advertiser and the customer. Then they started providing a free email service with much more data storage than anyone else at the time. A gigabyte of free storage in 2004, which was an amount that had only just a few years earlier started becoming available even on desktop computers, let alone on the cloud. And the term cloud didn't even exist yet. Of course, they were doing this in exchange for letting them see more of our own personal information in order to better serve us ads and perhaps better enable us to find whatever information it is we want. They soon started scanning physical books in order to offer search of what's inside books, not just on the internet. They started a map product in 2005, initially with just North America and the British Isles. And in 2006, they saw a competitor site called YouTube that had been able to start serving people videos on the internet, and they bought that. They started offering a translation service also in 2006, though this translation was not very effective until about a decade later in 2016 when they replaced it with a neural net. During this early period, their translation service was only a bit better than looking up words individually in a dictionary and replacing them. It had very little ability to accurately track grammatical relationships. Now, this turned out to be a very successful corporate strategy, and over this period, Google became an indispensable corporation that was as big as the giants of like IBM and Microsoft and Apple of an earlier generation. But it never really felt to anyone like a general intelligence. It just felt to people like they had more and more information at their fingertips for their own use. Now, something that was much less significant technically, but much more significant for people's experience of intelligence was the rise of voice assistants in the 2010s. In this period, speech-to-text transcription software started getting good enough that it was possible to interact with very simple AIs the same way we normally interact with humans through our voice. First, Apple introduced Siri, then a few years later, Amazon and Microsoft introduced their own, and then Google introduced their Google Assistant. All of these systems are very restricted. All they can do is a specific finite set of tasks that have been programmed in, including sending text to a search engine or to a notes app, as well as doing things on your phone. And yet, the ease of interaction with the voice made many people start thinking of them the way that they thought of things like the ship's computer in Star Trek. Now, in 2017, there was a major step forward with the development of the transformer and attention framework that enabled the production of neural net large language models. It was clear that these were much more powerful than any sort of text processing that existed before. And over the next several years, various larger and larger models were developed that got better and better at creating text of various sorts. Now, people who were following the field were captivated starting in 2018 when Google released BERT and OpenAI released GPT-1. And even starting the next year, they were already putting limits on these things because they were worried that these were dangerously powerful. But it wasn't until late 2022 when OpenAI did a very minor thing of creating a system prompt so that this language model could become a chatbot. And suddenly the public started paying attention. And in the next few months of 2023, all the other major companies did the same with their models. And so now there are many competing models that people can use. And in March of 2023, when OpenAI had teamed up with Microsoft to release their GPT-4 model, researchers at Microsoft published a paper called Sparks of Artificial General Intelligence, claiming that these language models are not just fooling people, but actually exhibit enough complex behavior to be said to be the beginnings of general intelligence. The idea they had is related to Turing's point with his test. Language is such a versatile medium for human thought that it can be used to pose many different problem types. The Microsoft researchers tested GPT-4 and saw that even though it hadn't been trained directly on images, it could draw from instructions. You could ask it, use this scripting language to draw a picture of a unicorn, and it did something sort of reasonable. And it could solve novel problems of a variety of sorts. It suggested that this was evidence of some true problem-solving ability and perhaps the spark of general intelligence. Now, it's clear that on some level, in order to be able to predict language, large language models must have some sort of representation of the world. But it's controversial whether the representation they have right now is anything like general. And many people think this is instead like the incident a few years earlier when an engineer at Google, Blake Lemoine, had convinced himself that Google's uh, uh, large language model, Lambda, at that time, was not just a general intelligence, but actually sentient. And now there are many companies like Replica, Character.ai, Chai, Wobot, and others that offer large language model-based characters for friendship, therapy, even relationships, and more. It's very hard to know which of these interactions will be helpful for people and which might be harmful, and there's likely great possibility for both. We know that throughout history, even as far back as antiquity, people have often been primed to overestimate the intelligence capabilities of systems that display even a little bit of intelligence. But we also know that there have been many extremely capable systems that people have underestimated, like Google in the early 2000s and early large language models before they took the chatbot form. We don't yet have any better way of saying what it is for a system to be generally intelligent than being able to convince people that they are. But we also know that people are very fallible and they will sometimes think a system is generally intelligent that is not, and will sometimes fail to recognize the amount of intelligence that is there in an artificial system or even in other humans.